So, welcome everybody to a talk that's called Programmable IP to Mitigate Human Suffering. My name is Stefan Adolf. I'm working for a company that's called Molecule. We're actually not a DAO. That was written a little bit wrong on that slide, but never mind. We are powering DAOs and DAO ecosystems for biotech funded by Web3. So the topic of programmable IP starts with the main primitive of the molecule ecosystem, and that is the so-called IP NFT. I don't know if somebody of you attended the talk that was taking place on this stage around an hour before by Athena DAO. This is one of our BioDAOs, and they were actually minting an IP NFT to capture intellectual property. But to answer the question, what's an IP NFT? There are several aspects to it. In a nutshell, technically, an IP NFT is nothing else than just a plain ERC-721 NFT, as you would imagine that. But on the other hand, what adds value to it is a combination of legal and smart contracts, right? So there are smart contracts behind that NFT, and there are legal documents and contracts attached to it. On the other hand, what is an IP NFT actually doing? So IP stands for intellectual property, obviously. It represents the future rights of that intellectual property while it's under development. So there are actually research projects in our case that say, I want to capture intellectual property on chain and sell that to other people or do things with it. We're going to see that in a second. What IP NFTs are doing, they're binding legal agreements and ownership assignments to a transferable asset. That means you can prove on chain that you are the actual owner of the intellectual property bound to the NFT. Now, the really cool thing about them is you can use them as building blocks for other protocols, right? So you can actually, in the simplest case, you could try to sell them on OpenSea, which nobody's really doing because they're quite valuable. But this is something you could do. You can fractionalize them. You can do whatever you want with them, actually. And most importantly, why are we building that? IP NFTs are used as investment vehicles to fund those or to fundraise for biotech research projects. And you see a little selection of DAOs that already are considering or even have already minted IP NFTs. One of the most prominent ones being Vita DAO. I don't know if anybody of you heard about them, but this is actually the largest DAO we're currently supporting with an incubator program called BioXYZ. So this is more or less powered by us as Molecule, but we are mostly building the assets for that kind of stuff. So one thing about this talk, it is rather technical because I'm the lead developer of the Molecule core developer team, and it's maybe not as philosophical as Benji would have presented that, who was actually talking this talk slot in the first place. So bear with me if you see some code or some JSON files during the upcoming 10 minutes. What we wanted to show you is how the IP NFT minting process itself looks under the hood. Now, if you're not a developer, but if you're interested in figuring out how this kind of stuff works, you don't have to understand anything. You can just go to our interface at testnet.mint.molecule.to and mint it on your own. We spent hours and hours and hours in making this foolproof. I guess everybody should more or less be able to use that interface to mint an IP NFT. So, the first thing you do when you want to mint an IP NFT is you need to get the number of the IP NFT you want to mint. And this is a very special reason. All the legal documents you're going to attach to it will refer to the ID you're going to create in the first step. And this is a process that has been permissioned before, and it's now completely permissionless. So you can just go to our smart contract, call the reserve method, which is absolutely public, and create a new IP NFT ID and use that one to refer to the intellectual property later on. Now, each IP NFT comes with a certain structure of metadata attached to it. This is what I was talking before. On the very right-hand side, you see a sample of how this metadata looks like under the hood. But the preview here in the middle is actually how it looks like on screen. And I attached lots of little pills explaining what's going on there or what you're going to have to put onto it, right? Maybe some of the most important things are definitely who is researching on that, who's the lead researcher of the project, which institution, maybe a university, has enabled that research in the first place, and a list of attachments that are going to be attached on that IP NFT in the background. Now, after you got your IP NFT ID reservation, you can start crafting legal documents around that. If you go to our website and use our official minting front end, you are able to do this on the website itself. So we have some templates for you where you can create those research, so those legal agreements automatically. But if you are a researcher and you know a little bit what you're doing, you will craft them on your own. So the first kind of agreement you're going to attach to an IP NFT is the so-called research agreement, and there are different flavors of them actually. The most currently prominent one is the sponsored research agreement, but we crafted something that's very unique to IP NFTs called the SAFIP. This is what our legal department was actually crafting. And those actually talk about what's going on in the research project itself. And this might not be to be disclosed to the public. This is usually confidential information. This is why you actually want to encrypt it later on. I'm going to show you that in a second. But the second agreement you're going to prepare is a so-called assignment agreement. And this template is also absolutely open source. You can just use the stuff we have prepared there. The assignment agreement is assigning the real-world intellectual property to the current owner of the IP NFT with the ID that you have reserved. You can actually, if you do this on a technical level, not on our front end at the moment, you can attach whatever you want. So if there are more legal documents that you want to attach to it, this is the place to collect them. Now, first thing you want to do technically is, and this is what you don't see on the front end obviously, you want to checksum all those documents because they're going to be referred to on chain. If somebody's downloading them later on, they want to prove that all those documents were the ones that have been attached while the IP NFT has been minted. This is more or less how it looks like under the hood. You can, if you want, you can use any kind of checksum algorithm. We're using SHA-2, or it's not really CatCheck, but it's the SHA-2 algorithm that is that's delivered by IPFS. So this is code we prepared. We have sample repos on it. I'm going to link to point to them in the very end of the slide deck. You can download them. You can try them out. You can try this on your own. Now, once you have checksummed them, you want to, as I said, encrypt certain documents because they potentially carry information that's not supposed to be disclosed to the public, particularly the research agreement. And there's a protocol, and I'm pretty aware that many of you might know that already. It's called LIT, which is allowing you to encrypt things or to store encrypted values in a decentralized way. And this is exactly what we're using to encrypt that part of the IP NFTs. So you as a developer, if you are one, you can use the procedure that we also have on our sample repos and encrypt the research agreement with a key that's then also encrypted, and the clear text key is only gonna be reassembled on client side. That means only people who are supposed to read the data will be able to reassemble that encrypted key on their machine. It's a peer-to-peer protocol. I don't want to give a talk about LIT protocol, but it seems kind of safe. They're on a clear path of decentralization. Many people's using that, and this is what we're also using for IP NFTs. Now, once you went through the process and encrypted that research agreement and got that encrypted symmetric key, you're gonna put that down for the minute and also keep the encrypted file somewhere. And you keep something that's called access control conditions. This is actually defining under which conditions somebody may decrypt the IP NFT attached data later on. We're gonna see, I guess, a sample of that in a second. This is more or less how it looks like. The encrypted symmetric key that comes out of the LIT protocol is actually just a binary string somehow. You can just put it in the metadata of the IP NFT. And the access control conditions is something that LIT protocol provides as a structure. This is, as I said, just explaining, or it's defining which kind of chain condition has to be there. So the caller of the LIT protocol API may receive the key shards that will enable reassembling the encryption key on their machine to finally decrypt the data. And if this is a little bit too much for you, you can imagine it like, if you hold the IP NFT ID, you can ask LIT protocol to please provide the symmetric key to decrypt the attachments, and they will do so because you hold it. If you don't hold it, they will not give you the shards of that private key, which is pretty interesting method. Now, one of the final steps is now you have to store that kind of stuff somewhere, right? So what we are doing, and I mean everybody else is doing this as well, you upload the data to some decentralized file system. I don't know, what we prefer is IPFS, and particularly Web3 storage, delivered by our friends of Protocol Labs, which is an awesome service to just, well, fire and forget. You can upload things. They're actually pinning them automatically. They're even queuing them to Filecoin storage. So this is a rather decent service to store data. And we are storing the images, the encrypted metadata, and the final metadata using that method. It all ends up with data that's stored on IPFS. And what you're supposed to do, you can actually add those links that come out of that service in your IPNFT metadata. One of the last steps here is we want to be legally compliant. And that means that when you mint the IPNFT, you actually agree to the terms behind that. Those are the terms and conditions you can find on our website. You can copy paste them to your service if you want to write it on your own. But this is not a sample. This is exactly the string that's supposed to be signed. And if you look closely, the attachments of the IPNFT are mentioned here. So those agreements are to be signed by the party that's minting the IPNFT. At the bottom, this is something you very likely might know. This is like a binary signature that was derived by the signing party that was supposed to mint the IPNFT. And you take that one down. Now, you add this term signature to the metadata, and now you upload this final metadata structure to some final location. And now here comes the final step. If you want to build a meaningful protocol in Web3, and the data itself is actually the value, you want to ensure that the data follows a certain structure. Otherwise, nobody else might be able to read that. How do you overcome that? So Ceramic has some answers to that. There are lots of other protocols that might solve that. But how do you do that? How do you enforce that on chain? It's not that simple. And what we are doing, we actually added a permission step in the very end. We are signing off your metadata. So if you want to mint an IPNFT, there is a little unfortunate step in the end where we are checking if your metadata is actually compliant to the IPNFT metadata standard, which is just a JSON schema. So this is what our service is doing. It's also checking whether you really have accepted the terms that I was shown in the slide before. And it's also checking something about the images, but I won't disclose what is actually checking there. So we are making sure more or less that the stuff you're minting is more or less really looking like an IPNFT. Once we are pretty sure that this is a good data structure, we are signing off a message for you that we are sending you. This is what you see on the right-hand side at the bottom. And now finally, you can call the mint reservation function on our smart contract that finally will mint the IPNFT. And if you look closely at those parameters, the last one is called authorization. This is what came out of the step before. So this is the authorization we gave you to mint that IPNFT on our contract. This is to be made to avoid spam, and it's made to ensure that the metadata structure is correct. One little side note, you also have to bring 0.001 Ether, which is our so-called symbolic minting fee, aka spam protection. So you cannot just mint as many IPNFTs as you want. You always have to pay a little fee. So we can be pretty sure you're not putting lots of useless stuff on that. You can actually, but you pay for it. This is what you will end up with. This is how it looks like when you look at an IPNFT on our website, but this is just how we are displaying that. Everybody could just use them, display in any way they want, and utilize them however they want. There is actually a pounds value written on this one. This is actually ValiDAO's first IPNFT that they minted some weeks ago. This pound value over there is not the price on chain. This is the initial amount that has been funded by a DAO that was buying that IPNFT when it was minted. This is not automatical. This is actually only metadata. Somebody put that value on and said, okay, I was granted like 228,000 pounds to start my research on that intellectual property. And now you have an IPNFT. So what? You have a representation of intellectual property on chain. What could you do with that? One very obvious thing is you can fractionalize that. And I was told I shouldn't have mentioned the term fractionalization because it implies certain things. This is why we call it tokenize. So what we're doing, we're tokenizing a token. We're tokenizing the IPNFT to a fungible token contract, which we are creating as a minimal proxy on chain. You as an IPNFT holder can just call that method. You can also use our very beautiful interface here to mint, I don't know, 1 million, you come up with a number, 10 million IPTs of that IPNFT. That will represent membership and governance rights over the development of the underlying intellectual property. So if you are distributing that IPT token to your, I don't know, community, to all the people interested in that kind of research, they can participate actively in the development of that research project. This is the whole idea. And many people are actually very much ready to pay money to gain access to those IP tokens, because they might come with lots of little benefits if you're interested in the research project, right? So if you say, I want to support that ValiDAO people and the researcher behind it, I'm ready to pay, I don't know, £10,000 just to have access to the token, which might entitle me to gain more access on data that comes out of the project. So nobody has to really own the IP NFT itself. This is just the base asset that might be sold one day to a huge pharmacy company, but the IPT is already entitling you to actually get access to certain kinds of data that's attached to the IP NFT. That's out of molecule scope at the moment. We don't really care how they're utilizing that. We're just enabling the Web3 assets or the Web3 asset classes for projects to utilize it. This is a sample how it looks like when you're actually selling off those IPTs to your community. We built a crowd sale contract in the middle of 2023. Extremely successfully. We built that so it's super generic. You can use that crowd sale contract for any kind of your community. I don't know if somebody of you maybe even have followed that up. So VitaDAO was fractionalizing or synthesizing or tokenizing the IP NFT from Viktor Korolchak, which was dealing with a research topic that I cannot explain because I'm a mathematician. I don't know anything about chemistry, but this is awesome research actually. And they were selling off a tiny amount, like 25,000 tokens for a certain funding goal. So this was a public crowd sale. Everybody could take part in it. There were some little tweaks on it, but what we figured out in the end, it was like oversold by 1,700%. So people were actually really after that one. Why did they do that? Because now the owners of those IPT tokens are members of the snapshot voting, of the snapshot community that you see on the right-hand side, and they actually start interacting with the research project directly. So they have some impact on what Viktor Korolchak and his team is going to develop in the future. Some other things you can do with IP NFTs. You can actually token gate other services. You can check whether somebody holds an IPT and disclose data for them. There is actually a feature that we are providing, which is called a public data room. So you can attach just public data. You can, I don't know, add lots of findings that you have as a researcher or stuff that's interesting for your investors, and upload that. And if you want, you can just token gate it in a way that only certain people, maybe IPT holders with a certain amount of IPTs on their wallet, may see the data. In a nutshell, IP NFTs, this is what you already guessed, are able to build on-chain intellectual property portfolios for those bio-DAOs that we are supporting by other means. And this is just a screenshot of what VitaDAO is presenting on their website. So they are actually, and I don't have the numbers in my mind, this is maybe what Vincent comes up with in some minutes. They are collecting intellectual property, or they're adding this to their portfolio, thereby growing the amount of investment volume that they have bound into their DAO ecosystem, thereby raising the value of the overall ecosystem that they are building. And VitaDAO is actually, if you don't know them, taking care of longevity research in general. Some other things without screenshots, what you can do is, this is really interesting stuff actually, nobody really knows if a newly existing research project is really that valuable as they claim, because you don't know the output. They're still researching, right? So how do you know if this is valuable? One thing that might tell you if something's valuable is if you expose it to the market. You say, well, you can buy shares of that. Not really shares, but you can buy actually, you could put money into it. If nobody puts money into it, it very likely isn't that valuable, right? But if people are putting money into it, well, it's an indicator that this is really valuable. And this is something you can do with IPTs. You can figure out a little bit, if people are ready to pay money for it, then it might have more value than other projects. And as I said, governance plays a major role here. You can have other shareholders or stakeholders of the longevity ecosystem, for example, have a saying in what happens next, what research area somebody should focus on, if you should raise more funds for the research projects, and so on. So it's actually more or less a governance membership thing. That's everything that I have on my slides. I put quite a lot of, 3 links at the bottom that might be valuable for you. So the documentation area, the minting front end that I was mentioning and showing, and of course our website, which we remade 2 weeks ago by our very awesome website team. And you're going to find me anywhere on Web3, also on a service called X. And don't forget to buy my friend's token. Thank you very much.
Thank you, Stefan, for a great talk. We have a few minutes for some questions.
Otherwise, I can also answer my own questions, right?
Absolutely. It's always useful.
Absolutely. If the audience isn't that great, isn't that large, I happily ask my own questions. But feel free. So if somebody of you has anything that comes up to your mind, ask me anything.
If not, you can find Stefan here at the conference, and we'll have a 5-minute break. All right?
So, thank you very much,
so much, Stefan.
Thank you.